The ground beneath Arizona is cracking apart right now. 10 massive fault lines stretch under your feet, and one of them already triggered the largest earthquake ever recorded in the entire Basin and Range region. Most people picture Arizona as dry, still, and geologically asleep. But the truth is the state is being slowly pulled apart, and the evidence runs hundreds of miles long, hidden in plain sight across the landscape. Every fault on this countdown has produced shaking that real people felt, real buildings absorbed, or real prehistoric ground ruptures that scientists can still measure today. None of these are theoretical. All of them are ticking. And by the end, you will see why the Arizona-Mexico border once shook so violently that the tremor was felt across 770,000 square miles. But first we start with number 10. At number 10 we have the Mesa Butte Fault System, a northeast trending zone of normal faults stretching well over 100 kilometers across northern Arizona between Chino Valley and Shadow Mountain. What makes this fault strange is that it cuts straight through the heart of the San Francisco volcanic field. The fault and the volcanoes are not separate stories. They are the same story. Major peaks like Bill Williams Mountain, Sitgreaves Peak, and Kendrick Peak appear to have erupted directly along this line. Smaller cones like Red Mountain and Mesa Butte sit on the exact same trend. Geologists believe the fault traces a much deeper, ancient zone of weakness buried in Precambrian basement rocks. The surface offsets are small, the structure beneath is enormous, and modern tremors confirm it is still alive. Amik the fang tu a good, would the fang tu toms all, vutis os polenwork. Coming in at number 9 is the Bright Angel Fault System, one of the most visible geological features anywhere in the Grand Canyon. It runs as a continuous zone of normal faults across a staggering distance, from Cataract Creek in the southwest to the Echo Cliffs in the northeast, and when you extend it through Monument Valley, the system spans more than 300 kilometers in total length end to end. Here is the strange part. The famous Bright Angel Trail follows part of this fault as it descends into the canyon, using the broken, weakened rock as a natural staircase through otherwise sheer vertical cliffs. Like Mesa Butte, this fault is thought to reflect a deep Precambrian zone of weakness that has been reactivated many times over Earth's history, with several eruptive centers of the Mount Floyd Field along its extension. Modern earthquake epicenters confirm it is still active today. Every time the canyon shakes, this system is part of the reason. It is one of the true structural backbones of the entire Grand Canyon region. At number 8 sits the Algodones Fault, lying in the Yuma Desert in southwestern Arizona, southeast of the city of Yuma. And unlike most Arizona faults, this one breaks every rule we expect. Most Arizona faults are normal faults caused by the state stretching apart. The Algodones is different. It is closely connected to the Great San Andreas Fault System in California, which changes the danger entirely. Some geologists have even considered it a possible continuation of the San Andreas itself. Most researchers classify it as a northwest trending zone of predominantly normal faulting along the very edge of that system. For the 90s, that was just called Tuesday. For the 90s, that was just called Tuesday. The proof of activity is right there in the rocks. This fault has displaced Colorado River sediments by at least 15 meters, which is enormous on a geological timescale and impossible to ignore. According to the U.S. Geological Survey, a rupture along the Algodones could produce an earthquake of around magnitude 6.7. That is enough to flatten unreinforced buildings and rattle every town in the region. Yuma has historically felt shaking from earthquakes originating in California and Baja California. The Algodones Fault is the local Arizona piece of that much larger tectonic puzzle, and it has not gone quiet yet. Coming in at number 7 is the Santa Rita Fault, running along the western base of the Santa Rita Mountains just south of Tucson. And the scars it has left on the land are massive. Fault scarps along this zone reach up to 7 meters tall. These are not subtle features. They mark the exact locations of large prehistoric earthquakes that violently shook this region thousands of years ago. The fault is approximately 58 kilometers long, and detailed studies of its scarps suggest it is fully capable of producing earthquakes as large as magnitude 7.3, which would be catastrophic for the area. Here is what should worry Tucson residents. The Santa Rita Fault has not ruptured in roughly 15,000 to 20,000 years. But geologists still consider it an active fault that is quietly building up stress. Detailed mapping and trenching show that at least two major rupture events have occurred on this fault over the past 200,000 to 300,000 years. The pattern is real. The cycle continues underground. For the Tucson metropolitan area, with nearly 1 million residents, this fault represents one of the most significant earthquake hazards in all of southern Arizona. It is sleeping, not dead, and the difference matters. At number 6, we have the Cataract Creek Fault System, sitting about 45 miles north-northwest of Flagstaff. And this one has a confirmed history of producing real, damaging earthquakes in living memory. It is a broad zone of dozens of fault strands, stretching roughly 20 miles north to south and 10 miles wide. This is not a single crack. It is a tangled network of breaks. 3 magnitude 6.0 to 6.2 earthquakes struck the Flagstaff area in 1906, 1910, and 1912. All three are believed to have originated right here in this same fault system within just a few years. And the system did not go silent after that. In 1993, a swarm of earthquakes near Valle, just south of the Grand Canyon's south rim, included a magnitude 5.4 and a magnitude 5.0 quake. The Cataract Creek system sits inside the northern Arizona seismic belt, which contains the greatest concentration of active faults anywhere in the state. That fact alone changes how seriously you should take this region. Geologists view it as one of the most likely sources of a moderate to large future earthquake in northern Arizona. The clock has not stopped. It is still ticking right under the forest floor. Coming in at number 5 is the Big Chino Fault, running through central Arizona near the city of Prescott. It extends roughly 30 miles from Paulden up towards Seligman, cutting through ranching country. What makes the Big Chino special is the data we have on it. It is one of the only faults in Arizona where actual paleoseismic evidence has been gathered through trenching and detailed fieldwork. The evidence suggests it produced a major earthquake of around magnitude 6 to 6.5, roughly 10,000 to 15,000 years ago. That sounds ancient, but on geological terms, it happened essentially yesterday. Here is the part that should grab your attention. The U.S. Geological Survey has modeled a scenario where the Big Chino and Little Chino faults rupture together, producing an earthquake of approximately magnitude 7.2. Such an event would severely impact Paulden, Chino Valley, and Prescott. We are talking about real towns, real homes, and real infrastructure that was never built with serious earthquake forces in mind. A magnitude 5.1 earthquake near Chino Valley in 1976 may have been associated with subsurface slip on the Big Chino Fault. Smaller tremors keep occurring, including a magnitude 3.8 event in July 2023. At number 4, we have the Toroweap Fault, considered one of the two most active faults in all of Arizona, and the surface evidence of its power is impossible to miss. It cuts across the western Grand Canyon, where the Colorado River crosses it near River Mile 179, and continues northward through the canyon and into southern Utah. Total displacement reaches roughly 250 meters. That displacement is responsible for creating Toroweap Valley on the north side of the Inner Gorge and Prospect Valley to the south. These valleys are not erosion features. They are torn open fault scars. Scientific dating tells a precise story. The Toroweap Fault crosses alluvial fans that are only about 3,000 years old without rupturing them, while it has displaced older landforms 30,000 to 400,000 years old. The fault zone is around 250 kilometers long, which makes it the longest mapped fault in the entire state of Arizona. Nothing else even comes close to that scale on the map. According to U.S. Geological Survey scenarios, a rupture on the southern Toroweap Fault could produce an earthquake of approximately magnitude 7.5. That makes it one of the most significant seismic hazards on the Colorado Plateau. Coming in at number 3 is the Hurricane Fault, running parallel to the Toroweap and meeting it near the Colorado River. Together they form the other half of Arizona's most active fault pair. Total vertical offset on this fault reaches up to about 400 meters. The towering Hurricane Cliffs, stretching roughly 135 miles along the western edge of the Colorado Plateau, are its dramatic surface expression. Those cliffs are the result of millions of years of repeated movement. Every jolt, every slip, every rupture stacked another layer onto a wall of stone you can still drive past today. Like the Toroweap, the Hurricane Fault crosses very young alluvial fans, in this case about 8,000 years old, without disturbing them. That provides a clean maximum age for its most recent activity. The southern section of the Hurricane Fault in Mojave County is capable of producing an earthquake of approximately magnitude 7.4. That kind of shaking would be felt for hundreds of miles in every direction, because the Hurricane Fault sits right at the boundary between the Colorado Plateau and the Basin and Range Province. It is one of the primary structures controlling earthquake hazard in northwestern Arizona right now. At number 2 sits the Lake Mary Fault System, stretching roughly 25 to 30 miles from Mormon Lake northward to the very edge of Flagstaff itself. And this one threatens an actual modern city. It is made up of dozens of active fault strands, and the topographic escarpment it creates is plainly visible across the landscape south of Flagstaff. You can see this fault from the highway. Volcanic flows millions of years old have been vertically offset along this fault, including basalt flows that have been displaced by more than 100 meters. That is not minor movement, that is significant slip. Geologists consider the Lake Mary Fault the single most serious earthquake threat to the city of Flagstaff. Not one of several. The single most serious. That ranking matters more than any other detail. If the entire fault system were to rupture at once, it could produce an earthquake of approximately magnitude 7. That would threaten more than 70,000 Flagstaff residents and damage unreinforced masonry buildings citywide. Even partial ruptures of just 1 or 2 strands could generate quakes in the magnitude 6 to 6.3 range. There is no version of a Lake Mary event that ends well for the region, because Flagstaff sits directly along major interstate, rail, and pipeline corridors. A large earthquake here could disrupt transport across the entire Southwest. The damage would not stop at the Flagstaff city limits. But number 1 is where everything changes. Topping the list is the Pidi-Akachi Fault, the source of the most powerful earthquake ever to significantly impact Arizona. And what it did still echoes today. On May 3, 1887, this fault near the Arizona-Mexico border south of Douglas produced an earthquake estimated at magnitude 7.6. That is the largest known event ever recorded in the Basin and Range Province. The surface rupture stretched for more than 40 kilometers. In places, it left a scarp more than 14 feet tall, a vertical wall of fresh earth where there had been flat ground before. And that scarp can still be seen today. More than 130 years later, you can walk up to it, place your hand on it, and feel the exact line where the ground tore open. The shaking was felt across a vast 770,000 square mile area, from Prescott to Yuma to El Paso, Texas. That is an area larger than most countries on Earth, all rattled by a single fault slip. It caused damage in Tucson, Bisbee, and other Arizona communities. Walls cracked, chimneys collapsed, and the entire territory of Arizona suddenly understood that earthquake country was not somewhere else. It was right here. Around 60 people were killed, almost all of them in Mexico. The death toll could have been far higher if the region had been more densely populated in 1887 than it actually was. Although the Pidi-Akachi Fault's epicenter sat just over the border in Sonora, its effects permanently reshaped how scientists understand Arizona's earthquake risk. Everything we know about the state's seismic future traces back to it. It is a clear reminder that even faults far outside the state's most populated regions can deliver devastating shaking. Distance does not protect anyone when the ground itself is the source of the danger. The same forces stretching Arizona apart today are fully capable of producing another major quake in the future. That is not a prediction, that is just physics applied to rocks that keep moving. So when you put all 10 of these faults together, a clear pattern emerges. Arizona is not the still, silent desert most people imagine. It is a slowly tearing landscape with a long memory. From the volcanic peaks aligned along Mesa Butte to the cliffs carved by the Hurricane Fault, the state's geography is the direct fingerprint of millions of years of earthquakes nobody alive ever saw. And the modern tremors keep coming. Small swarms, magnitude 3 and 4 events, occasional 5s and beyond. The ground is talking, and seismographs across the northern Arizona seismic belt are recording every word. The next major Arizona earthquake is not a question of if, it is a question of which fault, which year, and which community sits closest to the section of crust that finally lets go. So the next time you drive through Flagstaff, hike the Grand Canyon, or look out across the Yuma Desert, remember what is hidden beneath your feet. Arizona is not asleep. It is loaded, waiting, and listening.